Hello students. So today in this video we will solve our exercise 6.2 from the chapter triangles. So let's see what is the first question. So in figure 6.17. So in the 6.17 two figures are given, figure 1 and the figure 2. And according to this question, this DE parallel to BC. In both the figure, this DE is parallel to BC. Here also the DE is parallel to BC. So this DE and the BCs are the parallel lines. So we have to find EC in figure 1. Means this EC we have to find out in figure 1. And AD we have to find out in figure 2. This AD we have to find out in figure 2. Now let's see how we can solve this one. So see, in this figure, what is given the information? So given, what is given? Is DE parallel to BC. So one triangle is given, triangle ABC. And in this triangle, this DE parallel to BC. So from the Thales theorem or from the basic proportionality theorem, what we can say? By basic proportionality theorem, if in a triangle two parallel lines are given, then this line will divide the other two sides in the same ratio. That is, AD divided by DB will be equal to AE divided by EC. Now we will substitute the value of AD, DB, AE from this figure. So what is the value of AD given? AD is given 1.5, DB is given 3, AE is given 1 centimeter. We have to find out the EC. Now 1.5 divided by 3 will give 2. So this will be 1 by 2 is equal to 1 divided by EC. Now cross multiply. So EC into 1 is EC and 2 into 1 is 2. So what is the value of the EC we got? So EC is equal to, so EC value is 2 centimeter. Now let's see the question number 2. So in the question number 2, we have to find out the distance AD. This distance we have to find out. Say solution 2. So in triangle ABC, what is given? This DE parallel to BC. So a triangle is given and two parallel lines are given. So this parallel line will divide the other two sides in the same ratio. From the basic proportionality theorem or from the Thales theorem, we know this. So by BPT. So by basic proportionality theorem, what we can say? This AD divided by DB is equal to AE divided by EC. Now we will substitute the values of DB. DB is given, AE given, EC given. We have to find out AD. So AD divided by DB value is given 7.2 is equal to AE given 1.8, AC is given 5.4. Now simplify, we will get the answer. Now 18 3s is 54. So if we simplify this one, 18 3s is 54. So we will get 1 by 3. Now we will cross multiply and we will get the answer. So this will be AD into 3 will be 3 into AD. 7.2 into 1 is 7.2. Now AD will be equal to 7.2 divided by 3. So AD is equal to, this one we can write, if we remove this decimal point, after decimal point one digit is there. So in the denominator we have to write 10. Now this one divide. So if you divide 72 divided by 30, what will get? 32 is 60, 12, 34 is 120. So what will be our answer? The AD distance will be 2.4 centimeter. So what is the distance of AD? AD will be 2.4 centimeter. So like this we can apply the basic proportionality theorem and we can solve these questions. Okay, now let's see the question number 2. So according to this question number 2, EF are points on the sides PQ and PR respectively of a triangle PQR. So first let's construct the figure. So according to this question, one triangle is given, triangle PQR, and in this triangle on the side PQ one point is there, that is E, and F is the point on the side PR. So we have to check for each of the following cases, state whether EF is parallel to QR. Now if we join these 2 points, we have to check whether this EF is parallel to QR or not, and the ratio of the sides given or the values of the sides given. So PE given 3.9 centimeter, EQ given 3 centimeter, PF given 3.6 centimeter, and FR given 2.4 centimeter. So to solve this question, how can we check that this EF is parallel to QR? So here we have to apply the converse of the concept of converse of basic proportionality theorem. So from the converse of the basic proportionality theorem, we know that if a line divides the two sides of a triangle in the same ratio, that means if we divide PE divided by EQ, if we get some value, and if we divide PF divided by FR, we will get the sum value. If both the values are same, that means this line will divide the two sides in the same ratio. So if this line dividing the any two sides of a triangle in the same ratio, then this line will be surely parallel to third side. So we will check whether this divided by this and this divided by this are equal or not. If equal, then this EF is parallel to QR. If not equal, then EF is not parallel to QR. So first PE divided by EQ. So PE value given 3.9 and EQ value given 3. So if we simplify, it will be 39 divided by 30. So both is divisible by 3, I think. So 3 13s are is 39 and 3 10s are is 30. So we will get 13 by 10. Now we will divide PF divided by FR. So PF given 3.6 and FR given 2.4. So if you simplify this one, 36 divided by 24. So both the number is divisible by 2. 12 and this one 18. Again if we divide 6, this will be 9. Again divisible by 3. 3 3s are 9 and 3 2s are 6. So we will get 3 by 2. So here clearly we can see that PE divided by EQ is not equal to PF divided by FR. So since PE divided by EQ is not equal to PF divided by FR, therefore this EF is not parallel to QR. This is the sign of not parallel. Now this question number 2 and 3 also, it is the part of same question. So according to this question number 2, this PE given 4 centimeter, Q is given 4.5 centimeter, PF given 8 centimeter and RF given 9 centimeter, and we have to check whether this EF is parallel to QR or not. So see, first we will find out whether their ratios are same or not. PE divided by QE. So PE is given 4 and QE is given 4.5. So this one can be written 40 divided by 45, because after decimal point one digit is there. So that is why in the numerator 10 will come. So if you simplify by 5, what you will get? 5 8s are 40 and 5 9s are 45. So 8 by 9. Now we will check PF divided by FR. So PF given 8 centimeter and FR given 9 centimeter. So clearly we can see that this PF divided by EQ and PF divided by FR, their ratios are same. So from converse of BPT, what we can say? From converse of BPT, what we can say? Since PE divided by QE is equal to PF, here in place of FR we can write RF, because in the question RF given. So PF divided by RF. So their ratios are same. Therefore, this EF is parallel to QR. So since their ratios of the sides are same, so that is why this EF is parallel to QR. Now let's see the question number 3rd. Okay, now according to this question number 3rd, PQ value is given. PQ means from here to here. The complete PQ value is given. PQ value is given how much? 1.28 centimeters. Then PR given. PR means from here to here. PR distance given 2.56 centimeters. Then PE is given. PE is given 0.18 centimeter. This PE value, it is given 0.18 centimeter. And PF, this PF given how much? 0.36 centimeter. Now we have to check whether this EF is parallel to QR or not. This EQ distance is not given, FR distance is not given. Though it is EF distance and the QR FR or RF distance is not given, but easily we can calculate this distance. So solution number. See how can we solve? See, if we want to calculate the EQ distance, how we will get? If we do PQ minus PF, means from this distance, if we subtract this distance, we will get this EQ distance. So what we can do? EQ is equal to PQ minus PE. So PQ value is given how much? 1.28 minus PE. PE is given how much? 0.18. Now if we subtract, what we'll get? See, 1.28 subtract 0.18. So we will get 1.1 centimeter. So similarly, we can calculate the FR distance also. See, this FR will be what? This FR will be PR minus PF. So PR minus PF. So PR given how much? 2.56. minus PF is given 0.36. Now subtract, what you will get? 2.56 minus 0.36. 0, 2, 2. So what you will get? 2.2 centimeter. Now you see the EQ distance also known to us, FR distance also known to us. So EQ we got how much? 1.1 centimeter, and FR we got how much? 2.2 centimeter. Now easily we can find the ratio of their sides and we can check whether EF is parallel to QR or not. Now we will check this PE divided by EQ. So PE given 0.18 and EQ given 1.1. So if we simplify this, what we will get? This one 18. Okay, after decimal point 2 digits is there, that is why here 20 will come. Here after decimal point 1 digit is there, so that is why 10 will come. So 10 can cancel. This will be 18 divided by 110. So afterwards we'll simplify. Now let's see this PF divided by FR, how much we are getting. So PF is given 0.36 and FR is given 2.2. So again this will be what? 360 and this will be 2200. Because here after decimal point 2 digit is there, so 20 we have to write here. Here after decimal point 1 digit is there, so 10 can write here like this. So this will be 36 divided by 220. So both can be simplified by 2. 18 2 is 32. 110 2 is 220. So 18 divided by 110. Now easily we can say that PF divided by EQ is equal to PF divided by FR. So what we can write? Since PE divided by EQ is equal to PF divided by FR, hence this EF is parallel to QR. So from the converse of the basic proportionality theorem, we know that if the ratio of the sides are same, then the lines will be parallel to each other. Now let's see the question number 3. So one figure is given. This is the figure 6.18. So if LM parallel to CB, so according to this question, this LM and CB are the parallel lines. Also given this LN is parallel to CD. This LN also parallel to CD. So we have to prove this AB divided by AM divided by AB is equal to AN divided by AD. So let's see. So here we can see, okay, first we have to write given. So what is given? First information is given, this LM parallel to CB and LN parallel to CD. Then after given, to prove. So what we have to prove? We have to prove AM divided by AB is equal to AN divided by AD. So given, to prove. Next step is proof. So how can we prove this one? So here we can see one triangle, that is the triangle ABC. See, this is the triangle ABC. In this triangle, this line LM line, it is parallel to CB line. So if one triangle is given and parallel lines are given, so this parallel line will divide the other two sides in the same ratio. See, in triangle ABC. What is given? LM is parallel to CB. This information is given in the question. So one triangle is there and parallel lines are there. So what we can apply? We can apply the basic proportionality theorem. So by basic proportionality theorem, what we can say? We can say this AM divided by MB is equal to AL divided by LC. L. So this one we can give the equation number 2. So similarly, we have another triangle. That is the triangle ADC. In this triangle, this LN is parallel to CD. So you can write also in triangle ADC, this LN parallel to CD. This information also given in the question. So again, one triangle is there and in this triangle parallel line is there. So this parallel line will divide the other two sides in the same ratio. So again we can apply the BPT. So by basic proportionality theorem, what we can say? This AN divided by ND is equal to AL. So AN divided by ND will be equal to AL divided by LC. This one equation number 2. Now you see we got the two equation 1 and 2. In both the equation the right hand sides are same. So if in equation the right hand sides are same, we can equate the left hand sides. So what we can say? So we can say from equation 1 and 2 we get. So from equation 1 and 2 what we'll get? See, right hand sides are same, we can equate the left hand side. So we can write AM divided by MB is equal to AN divided by ND. But according to our question, we have to prove this AM divided by AB is equal to AN divided by AD. So how can we prove? Now we have to taking reciprocal. So if we take the reciprocal, what we'll get? This will be MB divided by AM is equal to ND divided by AN. Now we will add 1 to both the sides. Adding 1 to both the sides. So this will be MB divided by AM plus 1 is equal to ND divided by AN plus 1. Now we will take the LCM. So this will be AM. So MB plus AM is equal to AN ND plus AM. Now look at the figure. If we add MB plus AM, see, if we add this MB plus AM, we will get this AB. As well as if we add ND plus AM, this ND plus AN, it will give us the complete AD. So here what we'll get? We will get AB divided by AM is equal to ND plus AN. It will give us AD divided by AN. Now again we will take the reciprocal and we will reach to our answer. So again taking reciprocal. So what we'll get? AM AM divided by AB is equal to AN divided by AD. So hence proved. Okay, now let's see the question number 4. So in this question also figure is given, figure 6.19. So according to this question, this DE parallel to AC. The first information what is given, this DE is parallel to AC. This information is given. As well as one more information is given, this DF also parallel to AE. So we have to prove BF divided by FE. So BF divided by FE is equal to BE divided by EC. So let's see how can we prove. So first given, what is given? First information is given, this DE parallel to AC, as well as this one F, DF parallel to AE. This information is given. So after given, next to prove. What we have to prove? BF divided by FE is equal to BE divided by EC. So given to prove. Next is proof. So here we will consider some triangles. So see, first this triangle. This triangle name is ABE. In this triangle given, this DF, it is parallel to AE. So in triangle ABE, in this triangle what is given? This DF parallel to AE is given. So this information is given in the question. So in a triangle, one parallel line is given. So this parallel line will divide the other two sides in the same ratio. So what we can write? BF divided by FE is equal to BF divided by FE is equal to BD divided by DA. BD divided by DA. This one we can give equation number 1. Now we can see another triangle. That is the triangle ABC. In this triangle, this DE parallel to AC. This information is given in the question. So also in triangle ABC, this DE parallel to AC. This information is given in the question. So again we can apply BPT by BPT. Okay, here also we can write here by BPT. By BPT only we will get this information. So by BPT what we can write? BE divided by EC. This BE divided by EC will be equal to BD. This BD divided by DA. From the Thales theorem we know if the parallel line divides other two sides in the same ratio. So now this we can give equation number 2. This one BE divided by EC. Now if we observe both the equation, in both the equation the right hand sides are same. BD divided by DA, BD divided by DA. If in two equations the right hand sides are same, we can equate the left hand sides. So we can write from equation 1 and 2 we get. What we'll get? So BF divided by FE will be equal to BE divided by EC. So what we can write? BF divided by FE is equal to BE divided by EC. Hence proved. So this question also related to the Thales theorem or the basic proportionality theorem. Okay, now let's see the question number 4. Question number 5. In the figure 6.20. So in this question also figure is given. This is the 6.20. So in this figure, this DE parallel to OQ given. This DE parallel to OQ. Also given this DF parallel to OR. This DF also parallel to OR. We have to prove. So what we have to prove? This EF is parallel to QR. So let's see how we can prove this. So solution. First, what is given in the question? The first information is given. This DE parallel to OQ. And what is given? This DF parallel to OR. So given next to prove. We can write to show or to prove we can write. We have to prove EF parallel to QR. So given to prove. Next prove. See how can you prove this one? So here I can see one triangle. That is the triangle POQ. And in this triangle, according to this question, this DE parallel to OQ. So again you see one triangle is there, parallel lines are there. So we can apply the BPT or the Thales theorem. So in triangle POQ, in this triangle, this DE parallel to OQ. This information is given in the question. So we can write by Thales theorem or by basic proportionality theorem. So what we can write? We can write PE divided by EQ. This PE divided by EQ is equal to PD divided by DO. This one we can give the equation number 1. Now we can see another triangle. This triangle name is POR. In this triangle, this DF is parallel to OR. This DF and OR are parallel lines in the question given. So also in triangle POR, what is given? This DF is parallel to OR. This information is given. So one triangle is there, parallel lines are there. So what we can apply? We can apply the BPT. By BPT, or we can say, or we can write by applying BPT. So what we can write? PF divided by FR. See, this PF divided by FR is equal to PD divided by DO. Equation number 2. Now you observe both the equation 1 and 2. In both the equation, the right hand sides are same. So if in equations any sides are same, we can equate the remaining side. So right hand sides are same, we can equate the left sides. So we can write from equation 1 and 2 we get. So right sides are same, so we can write PE divided by EQ is equal to PF divided by FR. Now what you proved? PE divided by EQ is equal to PF divided by FR. Now let's look at the figure. So this was our triangle, not ABC, triangle PQR, and this one is the EQ line. So just now we proved this PE divided by EQ is equal to PQ divided by QR. And from the converse of the basic proportionality theorem, we know that if any line divides the any two sides of a triangle in the same ratio, then this line must be parallel to the third side. So already you proved this PE divided by EQ is equal to PQ divided by QR. So by converse of BPT, basic proportionality theorem, what we can say? This EQ is parallel to QR. Hence proved or shown. So in this way, here in this question we applied both the theorem 6.1 as well as theorem 6.2. That is, we applied the Thales theorem as well as the converse of Thales theorem. Okay, now let's see this question number 6. So in the figure 6.21, so this is the figure 6.21. In this figure, this A, B, C are the points on OP. This A is the point on line PO. B is the point on line OQ and C is the point on line OR respectively, such that this AB is parallel to PQ. What is given? This AB is parallel to PQ as well as this AC parallel to PR. This AC also parallel to PR. This information is given. We have to prove this BC parallel to QR. We have to prove this BC and the QR are two parallel lines. So first given. What is given? The first information is given. This AB parallel to PQ as well as this AC also parallel to PR. So given, next is to prove. So what we have to prove? This BC parallel to QR. So given to prove. Next step is prove. Okay, so how can you prove? So we will consider first triangles. Here like this one triangle is there. Triangle name is POQ. And in this triangle, this one is the AB line. So we have considered this POQ, this triangle. This AB is parallel to PQ. This information is given. So in triangle POQ, what is given in the question? This AB parallel to PQ given. So again you see one triangle is there and two parallel lines are there. So this parallel line will divide the other two sides in the same ratio. So applying basic proportionality theorem. So what we can say? We can say QB divided by BO is equal to PA divided by AO. So this one we can give as the equation number 1. Now again we can consider another triangle. That is the triangle POR. So in this triangle, this line, this AC is parallel to PR. This information is given in the question. So see, also in triangle POR, in this triangle which two lines are parallel? This AC parallel to PR given. So again one triangle is there, two parallel lines are there. So this parallel line will divide these two sides in the same ratio. So by basic proportionality theorem, what we can say by basic proportionality theorem? We can say that RC divided by CO, this RC divided by CO is equal to this PA divided by AO. PA divided by AO. This one we can write equation number 2. Now again you see, in both the equation the right hand sides are same. So if the right hand sides are same, we can equate the left hand sides. So what we can write? From equation 1 and 2 we get. So from this equation 1 and 2, what we'll get? This QB divided by BO is equal to RC divided by CO. So we proved QB divided by BO is equal to RC divided by CO. Now you see, we will consider this triangle OQR. Triangle OQR. This one is B, this one is C. So in this triangle, what we proved? This QB divided by BO is equal to RC divided by CO. So this one already we proved. So we know that if in a triangle, if any line divides the two sides in a same ratio, then this line must be parallel to the third side. From the converse of the basic proportionality theorem, we know that. From or by converse of by BPT, what we can say? This BC parallel to QR. Hence proved. So in this way we can prove this question. Okay, now let's see this question number 7. Using theorem 6.1. Theorem 6.1 means basic proportionality theorem or the Thales theorem. We have to apply the Thales theorem to prove this question. Prove that a line is drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. First, let's construct the figure. After constructing the figure, it will be easy for us to understand this question. So according to this question, let's suppose one triangle is given. Triangle A, B, C. And let's suppose this D point, it is the midpoint of AB, middle point. D point is the midpoint of AB. Now, through this midpoint, if I draw one line, through this midpoint, if I draw one line, and this line must be parallel to this line. So according to this question, you see, if a line is drawn through the midpoint of one side of a triangle parallel to the another side. So from this midpoint, I have drawn one line in such a way that this line is parallel to this line. Now we have to prove this. For example, this point is E. So this DE line bisecting the AC side. Bisecting means what? Means cutting DE line, intersecting or cutting this AC line into two equal halves. That means we have to prove this AE is equal to EC. So solution. First, what is given? Given, for example, D is the midpoint of AB. Now, if D is the midpoint of AB, we can write this AD is equal to DB. Because it is the middle point, so surely AD distance and the DB distance will be same. And also one more information is given. This DE parallel to BC. This line is parallel to the BC line. To prove, what we have to prove? We have to prove DE bisects DE bisects AC. That means what we have to prove? We have to prove this AE is equal to EC. So if we can prove this AE is equal to AC, that means E is the midpoint of AC. Or we can say this DE bisecting the AC line. So given to prove. Next step will be proof. Proof. You see, in triangle ABC, in this triangle, this DE parallel to BC. This information is given in the question. Now one triangle is there, parallel lines are there. So we can apply basic proportionality theorem. So from basic proportionality theorem, what we can say, this AD divided by DB is equal to AE divided by EC. Now this AD in place of DB, I can write AD because this AD and the DB are same. See, already we have written now in the question given, D is the midpoint and AD is equal to DB. So in place of DB, I can write again AD. So AE divided by EC. Why I can write in place of DB AD? Because D is the midpoint. So AD distance and the DB distance are same. So we can write the reason, since AD is equal to DB. Now this AD divided by AD will give us 1. So 1 is equal to AE divided by EC. Now cross multiply. So this will be AE is equal to AC. So see, already we proved this AE distance is equal to EC distance. So what does this mean? This means that E is the midpoint of AC, or we can say this DE bisects AC. So therefore DE bisects AC. Hence proved. So it was a very easy question. Okay, now let's see this question number 8. Using theorem 6.2. Theorem 6.2 means what? Converse of the basic proportionality theorem. Prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. First, let us construct the figure. So when we will construct the figure, it will be easy for us to understand this question. So let us consider triangle ABC. The line joining the midpoints of any two sides of a triangle. Let's suppose this D is the midpoint of AB and E is the midpoint of AC. Now, if we join these two midpoint, so according to this question, we have to prove this DE line is parallel to BC line. So, what is given in the question? First information is given, D is the midpoint of AB. If D is the midpoint of AB, we can write AD distance will be equal to DB distance. Also given, E is the midpoint of AC. If E is the midpoint of AC, we can say this AE distance will be equal to EC distance. Now, these two information is given. So, what we have to prove? We have to prove this DE is parallel to BC. So, given to prove. Next step is proof. So, how can we prove? So, first information is given, this AD is equal to DB. This one is given in the question. Now, this one if we write AD, this one is bring in the denominator. Here 1 will be left. Why 1 will be left? Because AD and the DB are the same. Same thing divided by same thing will give us 1. Because see, AD divided by DB. Sorry, AD is equal to DB. Since D is the midpoint of AB. So AD divided by DB is equal to 1. This one you can give as the equation number 1. Also this AE is equal to EC. So this also we can write AE divided by EC is equal to 1, because same thing divided by same thing will give us 1. Now from equation 1 and 2, in both the equation the right hand sides are same. So we can equate the left hand sides. So from equation 1 and 2 we get. So from equation 1 and 2 what we'll get? So AD divided by DB is equal to AE divided by EC. So now you look at the diagram or figure. This AD divided by DB is equal to AE divided by EC we proved. That means if a line divides any two sides of a triangle, then this line surely will be parallel to the third side. So by converse of BPT, or we can write by theorem 6.2, this DE is parallel to BC. Hence, so to prove this question, we applied the theorem 6.2, that is the converse of Hell's theorem. Okay, now let's see this question number 9. ABCD is a trapezium. So trapezium means what? Trapezium is a quadrilateral where one pair of opposite sides are parallel to each other. Any one pair of opposite sides are parallel. So in which AB parallel to DC and its diagonals intersect each other at point O. So first let's construct the figure. So one trapezium is given. So trapezium is A, B, C, D. So in this trapezium, this AB parallel to DC. This information is given in the question. And its two diagonals. So AC is the diagonal and BD is the diagonal. Its two diagonals intersect each other at point O. So we have to prove AO divided by BO is equal to CO divided by DO. So given. What is given? A trapezium ABCD. Also given this AB parallel to DC. This information is given. Next, to prove. We have to prove AO divided by BO is equal to CO divided by DO. Now, to prove this question, we have to construct something. So, given to prove, next step is construction. So, here construction is needed. Without construction, we cannot prove this one. So, what we'll construct? We will draw a line. So, we will draw, suppose ABCD. This one is OE. So, we will construct this line in such a way this OE line is parallel to AB line. So, draw OE parallel to AB. So, given to prove construction. Next step will be proof. Okay, see how can we prove? Here I can see one triangle. That is the triangle A, B, D. And in this triangle, from the construction we know this OE it's parallel to AB from the construction. So see, in triangle ABD, in this triangle OE is parallel to AB. So from where does we know this OE parallel to AB? By construction. So see, so one triangle is there, this line is parallel to this line. So what does this mean? This means that this line will divide the two sides in the same ratio. So we can apply the BPT. So by BPT. So by BPT what we can say? We can say this DE divided by EA, DE divided by EA is equal to BO divided by GO. This one we can give as the equation number 1. Again, we can consider another triangle. See, this is the triangle name will be ADC, and this one we have constructed. We have constructed this OE. So see, in triangle ADC, in this triangle also we can say this OE parallel to DC. So why does we can say this OE also parallel to DC? So see, in the question is given AB parallel to CD, and from the construction we know OE parallel to AB. So one theorem we know, the lines parallel to the same line are parallel to each other. Since AB parallel to CD, OE parallel to AB, so we can say that OE also parallel to CD. So by basic proportionality theorem. So what we can say? So by basic proportionality theorem, we can say that DE divided by EA, DE divided by EA is equal to, so see, DE divided by EA is equal to AO divided by CO. AO divided by CO. So this one we can give as the equation number 2. Now again, if we observe equation 1 and 2, in both the equation the left hand sides are same. So if the left hand sides are same, we can equate the right hand sides. So we can write from equation 1 and 2 we get. So from equation 1 and 2 what we'll get? This is the equation number 1. We can write BO divided by GO is equal to AO divided by CO. Now we will interchange their sides. We can write CO divided by GO is equal to AO divided by BO. Just we have interchanged their sides. So we have to prove AO divided by BO is equal to CO divided by GO. Again we can interchange the sides. So this will be AO divided by BO is equal to CO divided by GO. Hence proved. So in this way, by applying the BPT, we can prove this question. Okay, now let's see the question number 10. This is the last question from our exercise 6.2. Actually, this question is the just opposite of the question number 9. In the question number 9, the trapezium was given and we had to prove AO divided by BO is equal to CO divided by DO. But in this question, AO divided by BO is equal to CO divided by DO already given. We have to prove the given quadrilateral is a trapezium. So the first thing we have to do, we have to construct the figure. So one quadrilateral is given. Quadrilateral is ABCD. Now we don't know whether it's trapezium or not. So we have to prove this this quadrilateral is a trapezium. So their diagonals intersect each other at point O. So first information given. What is given? Given a quadrilateral given a quadrilateral ABCD. Also given this AO divided by BO is equal to CO divided by DO. Anything else? No. So given, next step is to prove. What we have to prove? We have to prove ABCD is a trapezium. So how can we prove this ABCD is a trapezium? We know that if in a quadrilateral any two pair of opposite sides are parallel, that means it is a quadrilateral. So if we can prove this AB and the CD are parallel, that means the given quadrilateral is a trapezium. So to prove this question also, we have to do the construction. Next, construction. So what we have to construct? So similar to the question number 9, we have to construct or we have to draw one line, OE line. In such a way we have to construct so that this OE is parallel to AB. So draw OE parallel to AB. So given to prove construction. Next step is proof. So proof. Now here I will consider one triangle. That is the triangle ABD. And in this triangle, just now we did the construction. This OE is parallel to AB. So we can write in triangle ABD or ADB, this OE is parallel to AB. From where we know? By construction. So triangle is given, parallel lines are given. So we can apply BPT. So by BPT what I can say? This DE divided by EA is equal to BO divided by DO. So this one I can give as the equation number 1. Now AO divided by BO is equal to CO divided by DO. This information is given in the question. So we will utilize this information. Now if we interchange the side, AO divided by, so you will bring the CO here, is equal to BO divided by DO. So why we did like this? To make in both the equation the right hand sides same. So now you see in equation 1 and 2 the right hand sides are same. So we can equate the left hand sides. So now we can write from equation 1 and 2. So from equation 1 and 2 what we can write? This DE divided by EA is equal to AO divided by CO. Now you see, if we observe this triangle is ACD. In this triangle, so what we proved just now, we have proved this DE divided by EA is equal to AO divided by CO. So now, if in a triangle, if any line divides the two sides in the same ratio, that means this line must be parallel to this side. So by converse of basic proportionality theorem. So from the converse of the basic proportionality theorem, what we can say? This OE also parallel to DC or CD. Now you see, this OE is parallel to AB. From where we know this OE is parallel to AB? By construction. Also what we got? Also this OE parallel to DC. From where we know this one? Just now we have proved. So this one we can write proved above. Now you see OE parallel to AB. OE also parallel to DC. So we can say that this AB also parallel to DC because lines parallel to the same line are also parallel to each other. So what we can write? Therefore, AB also parallel to DC. Now you see, we proved this AB and the DC lines are parallel. That means we have proved that this ABCD is a trapezium. Hence, we can say that ABCD is a trapezium. So in this way, we are concluding our exercise 6.2. Thank you for watching.